In this section, we're going to be talking about the basics of functions and their graphs. First, let's talk about what are called relations and also functions. A relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain, and the set of all second components is called the range of the relation. A simple example of a relation would be a list of names where we're listing the last name first and then the first name. So like Adams, John, Baker, Sarah, Smith, Lisa, and Smith, Russ. So each of our last names is being related to a first name. The first entry, which is the last names, would be considered the domain. So our domain would be Adams, Baker, Smith. Okay, and notice we don't have to write Smith twice, just Smith once. And our domain is our second entry, which would be John, Sarah, Lisa, and Russ. And there's our range. Building on that, a function is a relation in which each member of the domain corresponds to exactly one member of the range. So in our name example, this relation is not a function because it's pairing Smith with two different first names. Smith is paired with Lisa, and Smith is paired with Russ. Okay, most of our time in this course will be spent working with functions. A function can be represented by a set, equation, or a graph. Most of our work will involve functions as equations and graphs. For example 1, though, let's start by looking at a set and determining whether or not the set is a function. We'll also state the domain and the range of the relation. So example 1a, we have the relation in set form 1, 6, 2, 6, 3, 8, and negative 2, 8. Let's start with the domain and range. So the domain is the set of all the first components. So our first components are the numbers 1, 2, 3, and negative 2. So our domain, negative 2, 1, 2, and 3. Order is not important, but typically we put these in smallest to largest. And this does not need to be here. Sorry about that. The range is the second component. So our range, we have 6, 6 again, 8, and 8 again. So the range is 6 and 8. And notice we don't need to write 6 twice or 8 twice. Just having it in our list once suffices. Okay, now is this a function or is this not a function? Remember, to be a function, each member of the domain can only be paired up with one member of the range. So looking at our domains, 1 is paired up with 6, and nowhere else do I have 1 being paired up with any other number. 2 is paired up with 6, and nowhere do I have 2 paired up with any other number. Same thing for 3, and same thing for negative 2. Okay, so even though 6 repeats itself and 8 repeats itself, that's a number that's in the range. To be a function, we're only concerned with whether or not the domain repeats itself. So we'll say that yes, this is a function. Example 1b, we have 6, 1, negative 5, 14, 6, negative 3, 9, 4. So let's start with the domain and range again, like on the last one. Our domain is the first components, which will be 6, negative 5, 6 again, and 9. So negative 5, 6, and 9 is the domain of this relation. The range of the relation, 1, 14, negative 3, and 4. So negative 3, 1, 4, and 14. Again, order is not necessarily important, but typically we put them in smallest to largest numerical order. Okay. Is this relation a function? Well, in order to be a function, no member of the domain can be paired up with more than one member of the range. For this relation, 6 is being paired up with 1, and 6 is being paired up with negative 3. So because 6 is paired up with 2 different values, no, this is not a function.